Today we're looking at a failure I've identified with the Wurth 749010011A isolation transformer. That's a name only a mother could love. Wurth has recently changed the packaging on this, and it has caused a mechanical stress concentration that causes the wiring inside to fail. This is not like a normal IC. This is an isolation transformer, so it's that. This is not an electrical issue, so I'm not really going to go into the electrical details here. This is the old transformer. We're going to look at it first, and what we'll do is we'll flip it over. I have not removed anything. This is just what the bottom of this looks like. And you can see here that we have a bunch of ferrite material. I'm not sure if that's focused or not. Sorry, I don't have my glasses on right now. Here we go. So you can see we just have a bunch of enameled copper wire that's wrapped around these isolation transformers. It does a thing, it isolates things. Again, the electronics don't matter. The old design has a lot more support here because it has a narrower cavity. The new design, I'm going to show it from the front first. I have just started using this new design. So again, this is the old design here. And the new design, I'll push the old one out of the way. You can see same part number, but they've gotten rid of the bottom shelves on the old design. And so here's the new design, and you can see same part number and everything. This one is from the 13th week of 2024, and these old ones are the 48th week of 2019. I just happen to have some of these old ones around. So I've shipped thousands of these old ones. I've never had this failure occur. And on this new batch, out of 350 of these, I have 1, 2, 3, 4, 5, 6, 7 that are broken. That is an enormously high failure rate for a single part like this. The board this is on has 650 parts. And so a failure rate like this is very noticeable, and the failures are all the same, as we'll look at in a second. So again, here's the new part. It's again the same part number. There was probably a PCN, a part change notification. I never really saw it. It shouldn't, on the surface have any issues here, but if we look in here, you can see the way the wiring is on this new design here. There's not much enamel here. I can zoom way in. I took my Barlow lens off, so my scope is really close, so I'm not terribly used to it here. Let me get this back in focus. Yeah. So we are zoomed way in on just one of the channels, and without this Barlow lens, man, the focus, the field of view is quite limited. But you can see that there's not much enamel. I'm sorry, there's not much. There's so much going on right here. These wires are just able to float in air, and they are very, very thin. Typically, this is potted with a conformal coating of some kind. So if you look at the old design here, you can see that the old design actually has an edge. Make sure this is focused. It's way zoomed in. So it actually has an edge this goes around. So when they put this lacquer on, the wire is really well mechanically constrained rather, and there's no strain. The new design just doesn't have that, and you can see that this wire here, it does have enamel on it, but that's not always the case. Sometimes it's just like this one does not have enamel. In fact, I think I just found where this one broke. Maybe? Is this one I found before? Yeah. Here was the one I had before that I couldn't find the failure on, and it was right there where the enamel is gone. That's just by luck. Let's look at the actual failures on these. So every one of these has a mark where that failure occurred. So this one is the third pin from the top left. And once I find it in frame here, you can see, I'm gonna have to zoom out a little, it's wild. Okay, so this one right here, I need to get it in the proper focus. That's the bottom. Goodness, this is quite zoomed in. Here we go. That's better. All right. So third pin from the top left, and if you look at this, it looks fine under the scope. There we go, I'm getting some mad glare. Oh, I think the auto exposure is kicking in. Probably need to turn that off. All right, let's see. Okay, so look at this third pin. I'm gonna find my razor blade. It's broken. You can see it's just disconnected, and there's no lacquer there. So this one's lacquered and double twisted. That one has no lacquer and it is broken. None of these units have shipped. This is 350 placements with 7 failures. I've never shipped these. These were failing my final verification test fixture, and so I removed them, and here we are. So here is the next one. Again, the zoom is wicked crazy here. Here's the next one. The wire looks just fine, but I moved it prematurely and got some glare again. You can see that the wire is broken here as well. This is a disaster. Autofocus or the auto exposure is not going great. Okay, there's our broken wire on the second one. It's the rightmost pin. I guess I'm going to zoom out more. Okay. So yeah, there's that one. This is the top rightmost pin here. And so once again, see if I can do this right-handed. Yeah, top rightmost pin. Now this one is actually lacquered. It still failed though. Let me get this zoomed in. Okay, so this one has still failed even though the lacquer seemed fine. Here's the pin right here. You can see that it's just broken off of this connection point. And that wire is just so crazy thin. So that's not good. Here is another one here. This will be the third pin from the top left. We might have already done this one. I'm separating them now. Yeah, we moved that one already. That's this one here. Okay. So yeah, that one's just broken there, so I can take this and just move the wire there. Again, no enamel there, or no lacquer. This one is the third pin from the top left here. And once again, you can see this guy here is just fully broken. You can see it's just broken there. No lacquer there. The lacquered ones there are fine. So I believe that this is mechanical vibration from my cleaning process. I use an ultrasonic cleaner to clean these boards. And here's another one that's broken. So this one looks just fine. Note to self, turn off auto exposure. I'm gonna do that now. Let's see. Exposure off. Perfect. So now it's my fault. Oh man, it's so much better already. Okay, losing the glasses here. So here's pin 1 broken. Get the razor blade in there. Again, you can see how the enamel is there, but it's not totally there. It's disconnected at the end. And once again, we have a broken wire there. And this will be, again, third from the top left. And once again, the wire is not enameled there on this old one. So this wire is good, and it has enamel on it. They're holding it to the wall. This one has nothing, and it's just broken off. It seems like this wire here is routinely not enameled. So we have that's there, 2, 3. So there's that. So 3 of these 6, again, I had the one that I wasn't sure which wire was broken, but 3 of these 6 are broken on that wire, and the other 3 appear to be broken on the other side. in a slightly different way. Again, we've kind of already looked at them. It's there, but again, there's no lacquer holding that in compared to the other ones. Basically, if you look and see which wire is the least secured, that's going to be the one that is mechanically broken. And so it's this one here. These are good. What does this look like? Yeah, those are lacquered pretty well, so they're not coming off. This one looks not great, but it's not broken. So anyway, let's look at the data sheet. And I've highlighted a few things. This is not the complete data sheet, but I've highlighted a few things here. First of all, our reflow profile is just fine. We're still using leaded solder because you can still do that in the US. So we're fine on the temperature. I think the max is 250 or something. Yeah. Package reflow temp 260 class. Yeah, we're not getting anywhere near that. We're way, way lower than that, like 20, 30, you know, whatever lower than that. So there's two things I've highlighted. The first one says cleaning and washing. And cleaning and washing says washing agents used during the production to clean the customer application might damage or change the characteristics of the wire insulation, marking, or plating. So nowhere in there do they talk about the actual wire itself. They talk about the wire insulation, the marking, or the plating. They don't talk about attacking the copper. And you know, the cleaning agent I'm using, the Branson EC, is specifically designed for electronics. So the only thing it attacks is aluminum, which this part doesn't appear to have any aluminum in it. So it says washing agents may have a negative effect on the long-term functionality of the product. And so that is an indication maybe that it's attacking the copper or whatever. However, again, I've shipped thousands of the old transformer design. And that is this one again. And again, this old one has that nice shelf, and that enamel really holds the wire in there. And I haven't shipped any of these new ones yet. This is the first batch of these new transformers that I've used, and 7 out of 350 of them failed. That may seem like a low failure rate, but it is not. 7 out of 350 of a component is a huge red flag. I don't do math in my head, so that's a 2% failure rate on a single part. So that's pretty scary from a part like this for my product or whatever, as far as it getting bricked in the field and having to recall them. So what does that mean for my product? It means that I'm gonna have to replace by hand 350 of these parts. And of course, these are not cheap. These are like almost $3 a piece. So that's $1,000 in parts that I'm just gonna scrap. And then of course, all of the time it's gonna take to do that. Fortunately, I do have these reworking tweezers, and you can basically grab these. I'll make sure it's off and cool. You can literally just grab these off the circuit board. It takes about 3 seconds. But I've already conformally coded all of these boards too, and I just can't ship this product out and then have to deal with a recall later. So this really sucks. This new part is not enameled well, and I think that the solution, if I have to keep using this new part, is that I'm gonna have to pot every one of these, which honestly I'm surprised they're not potted as they are. You know, you could just put some kind of epoxy potting in here rather than this enamel, and then these wires would never vibrate. I am almost certain that this is not a chemical attack from the cleaning agent that I'm using. Again, because Branson EC cleaning agent is specifically designed to clean circuit boards. You know, Wurth has the caveat in here, you know, like, you know, washing agents may have a negative effect on the long-term functionality of the product. You know, I'm sure I read that when I originally designed this board and then tested it, didn't run into any issues. And again, the thousands of the old ones, I've lost it at this point. Is this the old one? Whatever. The thousands of these old ones that I have out there never had this failure happen. And so to have 7 fail out the gate Even though the other 343 units passed, and I do a pretty extensive test, sending quite a bit of data over these. You know, in an application with vibration, which my application has vibration because it goes in vehicles, you know, pretty scary, this new part. So I might end up, I don't know. I'm not sure what's going to happen there. I'm just kind of figuring this out. Wanted to share it. Super annoying. This is going to add days of, you know, figuring out what the solution is, reworking all of these boards. Trust me, these boards are not worth scrapping. These boards have a couple $100 a piece in parts on them. So I'm not going to scrap, you know, all of those boards because that would be a lot more expensive than the $1,000 to just replace this part. And so the question becomes, okay, was this a mechanical failure only? Was it an embrittlement caused by my cleaning agent, which again, none of my old parts have ever had this happen. So I need to play around with that some more, figure out, you know, look at the broken face, see if it looks like a chemical attack, a galvanic attack between the pad and the copper wire. But again, the cleaning agent I'm using is designed for electronics specifically and pretty much nothing else. So even though we have Wurth's caveat in here to not use a washing process, you know, I have to wash my board. I have to get all this stuff off for high voltage isolation and stuff. I will note, because I said that this is not the high voltage barrier on the product. This is actually only rated for 60 volts of isolation. I use AC coupled capacitors that are properly biased for that. Anyway, yeah, that sucks. There was one last note here. You know, due to constant product improvement, we might have part change notifications. I need to find their PCN, but I really do think that my intuition here is telling me this is a mechanical vibration issue. My ultrasonic wash process is a 10-minute process. That's a pretty high ultrasonic level. It's a very high level cleaner. And so I believe it's just vibrating these wires to death, specifically because the failure is happening where there's no lacquer, not where there is lacquer. So, and the connection from the wire here to this interface material, you know, I'm certain this is a copper terminal that's, you know, zinc or nickel plated, probably nickel. And so I don't think the galvanic corrosion potential is very strong there. But I will look into that, of course. It seems the correlation I have is that this failure is mechanical vibration due to ultrasonic cleaning. So I would think that this note in the manual here would say also the ultrasonic cleaning, the mechanical vibration from ultrasonic cleaning may damage this part. Oh, and also this part's not really rated for harsh vibration environments because we're not potting it correctly. This lacquer process here is, when it works, is working, but it seems like on the old one, it's not working well. And as I showed earlier, I lost the new one. The old design had a much better channel in here where the lacquer was much more likely to actually attach. Look at that nice, beautiful angle that bends the wire there. And so that forces this wire, losing the blade, to have to contact here because the wire comes up, it has this angle it has to come over. So you put lacquer here, and then you're guaranteeing to get lacquered at least to this point. And, you know, I say that, but I don't know that this one is. Oh, it is. Yeah, there's lacquer. Oh no, the lacquer we missed there. But also this stress concentrator here would keep this from vibrating. You can see that, like, look, even if that all vibrates down there on the wire, the stress concentrator on this solder joint right here is, the energy is absorbed by this mechanical angle here. And we just don't have that on the new part here. And the new part is just hooking up directly like that. And these are all lacquered well, The problem I have is that even though I passed this test, I don't know how much mechanical damage the ultrasonic cleaning process has done to the 343 that did not fail. Boy, that's a head scratcher. I think the answer is to fully pot the replacement parts on all of these. So literally take a reel of the, gosh, it's so annoying. I'm gonna have to take a whole reel of these. These come on a pick and place reel and a machine places them. And I'm gonna have to rip them off of that reel. And then I'm gonna have to pour an epoxy material in here. You can see that this is not gonna happen. You can see just my cynicism in this. To pot all of this in here. Maybe I could take a clear fingernail polish enamel and just manually inspect every single one of these parts before I then hand place it. Keeping this video PG-13. You know, you're allowed one fuck in PG-13, so I'm going to say it anyway. No. The answer is no, and unfortunately, you know, this footprint is not a common footprint. And so I think the answer is that I need to find a transformer design that does not have this deficiency, or Wurth needs to fix this. I really do think that this new package is inferior substantially because you know, I don't know. The easiest way, the fastest way Wurth could fix this would be to pot this bathtub all the way up, and then these transformers are never going to move. The copper is going to be embedded fully. It's wild to me that they don't do that already. So anyway, that's it's just annoying, and it means that the 350 of these that I just placed, I have to rework. And I mean, there really is no other answer to that, and it really sucks. Yep, part changes. I mean, people like me who don't like change, this is why I don't like change, because something has changed. I've used it thousands of times and I've never had problems with it. And it's the same part. Nothing, you know, nothing has changed electrically, but no, mechanically it is inferior. I think that I need to prove that this isn't an electrochemical attack, and the way you do that is you dump your ultrasonic cleaner, you fill it with deionized water and nothing else, and then you just test and test and test, and you know, that's a destructive process at that point. See if the failure can reproduce. Presumably I would need to test this 50 times to detect it once, because again, 2% failure rate means, you know, 1 out of every 50 of them are going to fail. And you know, the other 49, or you know, the other 49 out of the 50, they might be in a state where they're just maybe working and they're passing my tests. You know, I do run data through these, but you know, the bump and ship during UPS, or you know, the run over if you're, you know, FedEx. I hate FedEx. You know, it's possible that this product worked in my tester and then it was just barely holding on, and then it gets to you and it's no longer working, and you know, maybe another 2% of them fail, but the customer experience of having this product fail is not great, and so it means that I have to replace them all, because I just won't ship a product that I don't have full faith in. So it's pretty sucky. But anyway, that is that. Thanks for watching.